Probing prematurity in neurodevelopment, analyzing the role of preterm birth in brain morphology with magnetic resonance imaging of neonatal brains.
Premature birth is the leading cause of perinatal morbidity and mortality in developed countries, with over 15 million babies born preterm each year. The fetal brain undergoes substantial morphological changes in utero, increasing its volume, surface area, and structural connectivity. Thus, babies that are born prematurely or before 9 months of development within the mother's womb must undergo this development in the postnatal environment. Though clinical outcomes are improving, many preterm babies still require careful monitoring and encounter neurological diseases or developmental difficulties that may have long-term impacts. Thus, we wanted to answer the question of how premature birth affects brain development. In order to assess early brain folding and remodeling, we studied MRI scans of neonatal brains and compared their cortical thickness, brain volume, curvature, and morphology.
The MRI scans that we analyzed and rendered were with of neonates born at term at 40 weeks or born preterm at 27, 29, and 32 weeks, and later scanned at term equivalent age. These brain scans were drawn from the open source Albert Neonatal Brain Atlas. 3D brains of each subjects were rendered in FreeSurfer. FreeView was used to manually measure cortical thickness and compare brain structure volumes. The white matter and curvature surfaces of the left hemisphere of the brain were found using TK-Surfer. Curvature was analyzed in image J. These images show the curvature of the white matter in the left hemisphere, gyria represented in green and sulci in red. Higher gyral curvature values correspond with more intense green values, and higher sulcal curvature with higher red intensities.
Using FreeSurfer, we were able to obtain regional and global measures of brain volumes for the 4 neonatal subjects, such as the total intracranial and brain volumes of the regional volumes of the cortex, white matter, and gray matter. We found a negative relationship between gestational age and both mean cortical thickness and percentage of gray matter.
Positive relationships between green pixel value and gestational age, and between red pixel value and gestational age are observed. This corresponds to increasing curvature with increasing gestational age. Challenges include the limited number of subjects and lack of their medical histories. Moreover, the scans of neonatal brains have less contrast, so FreeSurfer was unable to correct all topology defects. This introduces inaccuracy in generating the curvature and white matter surfaces. Analyzing only the left hemisphere of the brain is also not completely representative of characteristics of the entire infant brain.
Based off of the initial findings, our data appears consistent with the results found in literature. These suggest that brain remodeling and folding could be delayed for neonates born premature compared to those born at term. However, premature birth appears to not have a significant unrecoverable effect in neurodevelopment. These findings have applications in clinical care, education, and research. Ultimately, given the limitations and challenges that we previously discussed, and the lack of understanding in the fields of prematurity, birth, and neurodevelopment at large, further research is required to understand the interactions of mechanics and biology on brain development. And here are our references. Thank you so much for listening.